world's first specialized mobile highway maintenance complex, which doesn't just minimize patching costs, it solves the speed and quality problems too. Here's how it works. Immediately on arrival, the complex automatically positions itself on hydraulic supports and turns on its signal lamps to warn motorists that road work is going on. Using indicator lights, the operator determines the area to be processed and selects the size of plug required. This concludes the operator's part of the job. The machine now goes into automatic mode. The complex applies various tools on its own, switching from one to the next as required. First, the machine accurately mills the surface contour of the section that is to be repaired. It then mills the inside to create a neat hole of the necessary size. Using a vacuum device, it removes chips and fragments of the old road surface and, if necessary, fills in the empty space formed underneath the asphalt with a special mixture stored in the machine's bunker. The machine then takes a plug of the appropriate size from its internal magazine and fits it neatly into the slot it has prepared. The whole tech cycle of the repairs has taken no more than 5 minutes. The plugs, stored chilled, are made from high-quality crushed granite and tar using the vibro vacuum method. After it's fitted, the plug warms up and expands to fill the gap between itself and the old asphalt, resulting in an exceptionally firm joint. The cost of this kind of repair is much lower than the cost of patching work, and the repaired section of highway will remain serviceable for significantly longer. What's more is the machine can work any time of the day or night and in practically all kinds of weather conditions. Our technology is universally applicable and solves the main problem of highway maintenance. Detecting damage early and putting it right in a timely fashion stops it spreading and reduces maintenance costs. Just a few of these machines can provide efficient and high-quality maintenance for the streets of an entire city, saving tens of millions of dollars in the process. With 10 or so of them, you can serve an entire megalopolis, performing 500 or more local repairs every single day. And according to public sources, these cities are currently allocating hundreds of millions of dollars from their budgets for patching work, and spending the money very inefficiently. To find out more about our technologies, visit the Dahir and Chat website.
Second prototype assembly. Here you can see the new base frame with the square bits on to locate the olives. I've also got bearings in the cogs now, and I've used these bearings mainly because it's what they had around, but they end up working quite well. As you can see, the bearings go over shoulders on the olives, and then the olives go through, and they have a square peg on the bottom of them as well, which means that they locate and self-orient them, and you see there they don't twist once they're locked in, which is quite handy. It means it all self-jigs when it's assembled. So there you go, and now we move on to the gears. Each of these gears has a slightly different meshing, so there's two different types of gears. So I've got two of one type and one of another. It looks like I've got a pair there. So we get the other one, and there you go, they mesh and the little cups line up, and then and you can see with the other one, there you go, all those line up nicely, so that allows the drive peg in the shuttle to transfer between the cogs. So the olives, as you can see, are slightly different, just for this prototype, to allow it to go round the ends there. Just the end ones are slightly different. So let's start putting them together. So we'll put the drive cogs in first, remembering to align the little cups, the pegs on the bottom of the shuttles. So there you go, that's those aligned. You see how they all fit quite nicely. So now we get the bobbins, and they just clip into place and self-orientate. So you do have to get them on the right end though. So that's the right hand one. The centre one, make sure the shape's the right way around, and just drop that one in. There you go, again self-locating. And the left hand one, there you go, again self-locating. Fairly simple. Now we just drop the bolts in. I like to use decent sized washers on these just to stop the bolts crushing the plastic on this build anyway. It's all fairly simple. It's one of the things I like about 3D printing is as long as you've got the print tolerances right, it's almost like designing and assembling. There's very little in the way of manufacturing to do. I do tend to drill out some of the holes slightly, and as you can see, sometimes just getting things to fit, it's all quite snug, which is good when you're wanting things to self-align. Okay, drop on some more washers, so they sit on there nicely, and then we'll just put these other small washers on top, and then just spin down the nuts. These are only really holding the olives in place, so they don't really need to be torqued up very tight at all. They just need to be tight enough to hold all the faces flush against each other so everything lines up properly. So that all goes together quite nicely. Then this is a thumb wheel, really, just to allow me to turn the cogs by hand for this prototype. Obviously in the later machine that will be driven by a motor, but I need to figure that one out later. So again, a centerpiece that just snaps in, and then we can drop a bolt in, and there we go. washer and the nut that goes on. So there we go, that's everything assembled. It runs quite freely. Much better than the first prototype anyway. So now we want to remember to drop the bobbin in while we're putting the top piece on, because it's a single solid top piece. You have to get the bobbin in before you attach it, so it's just a matter of dropping it in, and then we just bolt it up. These can be a little snug, but again, because of the 3D printing, the tolerances, all I usually have to do is just open the holes up slightly with a drill bit just to clean them out, really. These are 3mm bolts, 3mm drill bit, and then a little bit of pushing and shoving, and the bolts will drop in quite nicely. There we go, and one more. There's one more bolt hole in there, but it doesn't really need populating just to show this. Minor mistake here coming up, it won't move. Damn. So what's caused that is I didn't put the peg and the bottom of the shuttle into the bucket to carry it. So I'm just going to speed this up, and I'm going to drop that back in and locate it and put the faceplate back on, and there you go, running very smooth and really quite nice to hold. There you go. So yeah, really pleased with that prototype, and based on that prototype we moved on and printed a load more segments. As you can see, going to need 8 of those to make up the full machine.